Alright, so what we've been working towards and what we're going to be doing in this unit is trig proofs, which are a lot like algebraic proofs where you'll have an equation and you just want to manipulate one side using our identities to get it to look like the other. So we're going to go through, let's see, we're going to go through 3 proofs. Actually, let's just do 2 proofs and then I'll save a couple for class. We're going to go through 2 here just to kind of see how they work, and then we'll go through a couple more in class tomorrow before you have time to work on your assignment. So here's our first one. So the equation that's given to us, tangent theta plus cotangent theta equals secant theta times cosecant theta. So you'll be given an equation, and what you want to do is pick a side to work with. And usually the side I pick to work with is not going to be the side that I box. So what I mean by that is I'm going to look at this and go, which one do I see right away somehow I can be rewritten? So can I rewrite this side pretty easily into using our identities? Yeah, I can think of a couple ways to rewrite a tangent and a couple ways to rewrite a cotangent. And then I know with adding, I'm probably going to have to get a common denominator. So I can kind of map out in my head a little bit of a plan for what I could do over here. Over here, I see that I can maybe do a reciprocal, but multiplying, and then what? I don't have much after that. So I'm going to choose to box this side, meaning I'm not going to touch it. I want to see, can I play with this side and make it match that side? So what I'm going to do is not touch this side. I box it. I'm not going to touch it until the end. So here I'm going to say, okay, how can we rewrite a tangent? Well, like I said, I thought I could rewrite it as sine over cosine. And then cotangent I can write as cosine over sine. Alright, so next I go, okay, I have to get a common denominator so that I could actually add these 2 fractions together. So for my common denominator, it'll be sine theta, cosine theta. So this one has to get multiplied by sine theta on top and bottom, and this one by cosine theta on top and bottom. That way I get my common denominator. So on top here, when after multiplying top and bottom, I'm going to get sine squared theta plus, and then on this one I'll have cosine squared theta. Okay, so then I look and I see what I have. I notice that I have sine squared plus cosine squared. Well, in my head I'm thinking, hey, isn't that a Pythagorean identity? And so I'm going to rewrite this as 1 over sine theta cosine theta. Okay, so what can I do now? So if I separate this into 1 over sine theta times 1 over cosine theta, so just separate the multiplication into 2, and then do reciprocal identities. The reciprocal of sine is cosecant theta times reciprocal of cosine is secant theta. Isn't that exactly what I was trying to match? And that's when you know you're done. So again, with these trig proofs, start by figuring out what side of the equation you see a few things you might be able to do, so that you might have a little bit of a plan to get you started. And this is also where you can use some of those 7 strategies we went over, changing things to sine and cosine, and all that kind of stuff. You can use those ideas to help you get started. So we're going to work with just one side after we've picked it, and try to work that one side until I get the exact same expression that I boxed. That's how I know for sure that these two will equal, and that proves the equation. Okay, so we're going to do, like I said, one more here. Let's see, which one do I want to do? Let's do this one. So this next one I'm going to tell you right now, there's two ways you can do it. So we're going to go over one of them here, but if you see a different path you might want to try, make note of that, and we'll see about doing it in class. So you can see that there's more than one way that you could prove any of these. So this next one is sine x cosine x plus sine squared x all over sine x equals cosine x plus sine x. So when we start here, again, I'm going to look at both sides of the equation to see which one do I maybe have a plan for. So when I look over here, I see multiple terms that have sine, so that means I could factor out a sine. Over here, let's see, I don't really have anything. It's already in very much simplified form. I can't think of any way I can easily rewrite it. So I'm going to go ahead and box that side, since I'm not really sure how I would go about it, and work with this one to see if I can get it to match that. So like I was saying, I noticed that on top both of these had a sine x. This one has 2 sine x's, this one has 1. So we can take out a GCF of sine x. And when we take out that GCF, we're left with inside with a cosine x and 1 sine x. This is all over sine x. Once this is out and being multiplied, we can cancel. So cancel the sine x's, and we're left with cosine x plus sine x, which matches what we boxed. So therefore, we know we're done. So like I said, there is another way that you could have done this one that that we can talk about. So if you see or think you might know a different way to go about it, there is a second way that we can prove sine x cosine x plus sine squared x all over sine x is equal to cosine x plus sine x. And I'll tell you this, it's not longer. It actually is about the same amount of steps. So just because it's a different way, it takes about the same amount of work. It's just a matter of what you see. So if you have an idea of something else you might want to try it. And we'll go over the second way to do this in class tomorrow. But this is really all there is to trig proofs, is just trying to figure out what side to work with, and then work with it until you get to the other side.